I'm having a hard time understanding recurrence relation.
Oh, that's easy. I'll help you.
Wow, thank you.
So basically, a recurrence relation is an equation which represents a sequence. It helps in finding the subsequent term depending on the preceding term. The simplest form of recurrence relation is when it only depends immediately on previous term. So, do you understand now?
Yeah, that was easy.
Now let's dive into it more deeply.
Hey, let's go.
Okay guys, this is a poster to summarize all of the things that I will explain today. Fibonacci is named by Leonardo of Pisa, known as Fibonacci, which the number starts with 0, 1, 1, 2, 3, 5 and so on. Each numbers are considered as a term represented by Fn, where n is numbers of positions in sequences. Like for example, if we start with 1, then 7th term will be F7, while F1 is the first term. But if we start with 0, the 6th term will be F5, while the 7th term will be F6. So if you notice, in our lives, majority of flowers have these numbers of petals. Can you see the pattern? So as you guys can see, this is the previous sequence of numbers. 3, 5, 8, 13 and 21 and so on, but I will stop until 21 only. So we take 3 as our first term, and then 5 as our second term. Then we're gonna prove, is this a really Fibonacci numbers? So based on Fibonacci numbers, the formula will be like this: Fn equal to Fn minus 1 plus Fn minus 2, where n minus 1 is the previous numbers of Fn and Fn minus 2 is the two previous numbers before Fn in a sequence of numbers. Okay, we have first term and then we have second term. Then next, maybe we will have a third term, which is F3. So F3 minus 1 plus F3 minus 2. It will be F2 plus F1. So what is the second term? The second term is 5, while the first term is 3. So we're gonna replace it. F2 is 5, F1 is 3. It equals to 8. Okay. So, we're gonna see the answer is the same as in the sequence. But, if you don't feel satisfied with your answers or your provings, so let's try to find F4. So, F4 equal to F3 plus F2. And then F3, what is our F3? So, our F3 is equal to 8, while our F2 is equal to 5. So based on our sequences, this is our first term, this is our second term, this is our third term, this is our fourth term. So our fourth term is 13. It's same as 13 here we got. So 13 here we got is F4, the fourth term. So it is shown that these petals sequences is actually an application of Fibonacci numbers. So if you guys want to know more about the Fibonacci and the other applications that related to Fibonacci, yes, you guys can search it. These are just the other applications you guys can see.
Hey, what are you thinking about?
I am thinking about the game called Tower of Hanoi. The rules are, you can only move one disc at a time. You can only move the top disc and you cannot put bigger disc on top of smaller disc.
Did you know? Tower of Hanoi is the application of recurrence relation. Therefore, we can just solve it. Application of recurrence relation, Tower of Hanoi. What is the aim of Tower of Hanoi? From the initial condition, all the discs stacked in the first rod, we aim to reach the final condition which all the discs stacked in the third rod. You can try to simulate it yourself. First, we are going to begin with the initial condition with all the discs are placed on the first rod, as you can see here. So we're going to have n to represent all of the discs, the total disc, which in this case is 3. To transfer the top disc, we're going to use this formula, because from the total disc, we're going to keep decreasing because we're going to move it to the second rod. So it's going to be like this. So on the first rod, the two discs are no longer there. So for the formula to move the upper disc to the second rod is hn minus 1. One move will be used for the largest disc, which is this one, to be placed on the third rod. So on the first rod, there will be no disc, and the largest disc will be on the third rod. So to move the upper disc, the rest of the upper disc on the largest disc here on the third rod, we're going to use this formula again. So it will be 2hn minus 1. So it's going to be 2 times. So we're going to end up with this formula, which is hn represents the number of moves. This one move represents for one move for the largest disc, and this one, like I mentioned earlier, this is for the upper disc. So this is the formula that we got earlier, which is the recursive definition of Tower of Hanoi. Now we're going to use this formula to find the explicit form of it. As you can see from the formula, this n minus 1, we can use the iterative approach to see the pattern. As you can see, I replaced the n minus 1 with n minus 2 and n minus 3. And this is the continuation of it because I am seeing more of a pattern. Notice that I'm replacing h1 with its initial value, which is 1. And to simplify all of this, we can use geometric sequence to finally end up with the formula 2 to the power of n minus 1. We can use the formula of geometric sequence to finally end up with this formula 2 to the power of n minus 1. Let's say we want to find out the total moves needed for 5 discs. So we will end up with 31 moves. That's how you can solve Tower of Hanoi.
What's the problem, honey?
I want to put our son's money on a bank, but I can't decide whether bank A or bank B.
Don't worry, let me help you.
Okay, so let's say that we want to deposit our son 2,000 ringgit for 18 years. For bank A, give us interest 11% to compound it annually, and bank B give us 8% interest to compound it annually. Let's calculate for bank A first. We will be using recurrence relation to solve this problem. So let Pn denote the amount in the account after 18 years, which Pn satisfies this recurrence relation, which Pn is equal to Pn minus 1 plus 0.11 times Pn minus 1, which equal to 1.11 times Pn minus 1. And our initial value, which is 2000, we will be using forward substitution to get its pattern. So firstly, P1 is equal to 1.11 times P0. P2 is 1.11 times P1, which equal to 1.11 squared times P0. P3 is 1.11 times P2, which equal to 1.11 cubed times P0. P4 is equal to 1.11 times P3, which equal to 1.11 power of 4 times P0. So we have got it patterns, which is, you can see that Pn is equal to 1.11 times Pn minus 1 which equal to 1.11 power of n times P0, and we substitute the P0 value and substitute the n value, which is 18, and we will get that 1.11 power of 18 times 2000, which equal to 13,087 ringgit and 15 cents for bank A. For bank B, we will be using the same way, which we will only replace the value here with 0.08 because now it is 8% interest. Just now, for bank A it is 11% interest. So we will get 1.08 times Pn minus 1. For P0 is same value. We will be using forward substitution, which is P1 is 1.08 times P0, P2 is 1.08 times P1, which equal to 1.08 power of 2 times P0, P3 is 1.08 times P2, which equal to 1.08 power of 3 times P0, P4 is equal to 1.0 raised to the power of times P3, which is equal to 1.0 raised to the power of 4 times P4, P0. Then we have got it better, then we can say that Pn is equal to 1.0x times Pn minus 1, which is equal to 1.0x power of n times P0. Substitute the P0 and 18 value we did like just now, and we will get 7,992 ringgit and 4 cents. Therefore, after 18 years with our deposit 2,000 ringgit, we will get that bank A is 13,087 ringgit and 15 cents, and bank B we will get 7,992 ringgit with 4 cents. And I think it's better for us to choose bank A because it gives us more value after 18 years.
Do you agree with me?
Yes, thank you, honey. Okay, the 2H problem. So by Stephen Ram, Okay, the problem is when you have a 100-story building and 2H, you can drop an 8 from any floor. And you would like to know the lowest floor that will break an 8. The lowest 8 breaking floor could be any floor, with equal probability. So you would know the right floor until you actually drop an 8 there and watch it break. Your 8s are totally interchangeable and won't get fatigued, no matter how many times you have dropped them. So this is the example when you drop an 8 from the first floor and it's break. So when you drop an 8, it will either break or it won't. If the 8 breaks, then any greater floor would have broken it as well. So when the second floor and the third floor, when you drop an 8 from second and the third floor, it will break. If it survives, then it also would have survived any lesser floor. So let's see another example. So when you drop an 8 from the second floor, it's break. And third floor, it breaks as well. Okay, what is the minimum number of trials in which you are guaranteed to find the lowest 8 breaking floor? So the solution. Before we start any calculation, we have to solve the 1-8 problem. What is 8 actually? So it's actually when we can't afford to lose our 1 and only 8. So we are forced to start at the ground floor. If the 8 breaks there, then we have found the right floor. Otherwise, we get to keep our 8. And we can try again with the higher floor. So the distance we can fully explore with 1/8, and T trials is D1T equals to T. D1 means you have 1/8. Bracket T means that number of trials equals to T. So T need to be more or equal to 0. Okay, now we are ready to solve the 2/8 problem, where we are given 2/8 and T trials. Okay, so we know we have to drop an 8 from some floor, right? If the 8 breaks there, we have to explore the lower floor with 1/8 and T minus 1 trials. If the 8 survive, then we can move to the upper floors with 2 8s and T minus 1 trials. Okay, so the formula is like this. D2T equals to D1 T minus 1 plus 1 plus D2 T minus 1. So D2 means that you have 2 8s. T means T trials. Okay, D1 is the first trial, and plus 1 is basically when the 8 survive and you move to another floor. So this is the second trial with 2 8s. Okay. So using the solution of 1/8 problem, we have this. Then we simplify it. Okay, first we drop an 8. We drop an 8 and the 8 survive. So we plus 1. Okay, and then we simplify it, become T. Because T minus 1 plus 1 is equal to T. Plus you have 2 8s right now and another trial. And then you get this one. So eventually, you will get a pattern like this. T plus T minus 1 plus until you get the trial becomes 0. Plus 1 is basically when the 8 survive, it will continue to another floor. Okay. When we are out of trials, we can't explore any further, no matter how many 8s we have. So it becomes 0. Okay. So we see the pattern here, and we can give some new form of this, which this one, T plus 1 over 2, which is come from this formula from the textbook itself. In particular, if we have 2 8s and 13 number of trials, the answer is 91. And if there's 2 8s and 14 number of trials, the answer is 105. So even though there are 100 floors to check, we can only use 2 8s. We are guaranteed to find the lowest 8 breaking floor within 14 trials. And that's it from me.